Welcome. In this series of short videos, we will look at topics common to both the PowerBasic console and Windows compilers. Today we will look at the PowerTime class. We're going to do today's video in 3 parts. We are first going to look at date validation. Secondly, we're going to look at time periods. And finally, we're going to look at file times. In order to make our work in date validation easier, we're going to add one of our pre-existing function libraries, the date functions library. So we're going to create a function to do our date validation. Within your applications, you may well have to validate dates coming from a number of sources, either dates the user themselves have keyed in, or dates coming from external data sources. So we've populated this local date string variable with the 29th of February 2025. Date formats vary throughout the world. This is the UK date format, which is day, month, year. The American date format is month, day, year. We have functions within our date functions library to support both of these date formats. So we're going to call one of the functions first of all to validate this UK date format, called fun_is_date_valid dd_mm_yy_yy, taking a single parameter, which is the date in that format. We will have a look at the function itself within the library in a moment, but first of all we'll run the application to see if this returns true or false. If it returns true, then the date is considered as being valid. If it returns false, then the date is considered not to be valid. So as we can see from the screen, the 29th of February was not a valid date, as 2025 is not a leap year. If we put a different date in, say for example the 29th of March 2025, and run the application once more, we'll see that it reports that that is indeed a valid date. So now we can set the system up to validate an American formatted date. First of all, we will populate it with the 29th of February. And we're calling a slightly different function, which takes its date in a different format, which is the US format. If we run the application now, we'll see that it reports that the 29th of February in the US format is not a valid date. If we amend our date to be the 29th of March and run once more, we'll see that it reports that the 29th of March in the US format is indeed a valid date. So how do these functions within our library actually work? Let's have a look at the code. So if we bring in our date functions library, hit the F2 to get the list, and we can see our 2 functions here, the date valid for the UK date format and the date valid for the US format. If we look at one of these, we'll see all it's doing is it's chopping up the past parameter, the date, into year, month, and day variables. We're then calling another function called isDateValid. And as you will see from below, we're doing exactly the same approach for the American format. We're taking the date format in the US format, month, day, year, and populating the same 3 variables and calling the same function. So both functions call this underlying function. And within here, you can see we're making use of the PowerTime class. We're populating a variable as a PowerTime variable and defining that as the class PowerTime. PowerTime has a number of methods which we can make use of to populate the variable we have just created. This variable object has a method called newDate. This allows it to pass the year, month, and day and set this up with that information. If that gives us an object result which is OK, then no error occurred. Therefore, we were able to populate the object with that particular date. Therefore, the date must be in a valid format. If an error occurred, then the date is not valid. This gives you a very easy way of telling whether a date is valid or not. So now that we've found an easy way of validating dates from a string, let's now look at time periods. We're going to take the same approach here and we'll call a new function called timePeriods, which is going to have the code in it. So here is our function which is going to handle timePeriods. We're declaring a local variable as iPowerTime and setting that up to make it equal to the class PowerTime. So now we have our PowerTime object, we can now manipulate it. We can set the values stored within that variable to now. That is the current date and time. We can interrogate that object to pull out the day of the week, the date string, and the time string, either in 12 or 24-hour format. This is done very easily using these three methods. If we run that now, we'll see it displays now as being Thursday, the 20th of March, at the hour 15:18, which is in 24-hour format, 3:18 p.m. PowerBasic automatically displays the date in your local date format. So if you were running this on a computer set to a regional setting of USA, it would show the date string as month, day, year. So now that we've stored the current date and time in our dateCalc object, we can now prepare a future datetime object, as we did before, but we'll call this one future date, and we're going to add 4 hours onto the time. Using the add hours method, it takes a single parameter, which is the number of hours you wish to add on, or if it's a minus, the number of hours you wish to remove. We can then use the same approach we did before to print the details out to our log, displaying the day of the week string, date string, and time string 24. So we can see from here we have advanced the time by 4 hours. If the number passed as a parameter is positive, we're going to be adding this. If it's negative, we're going to be subtracting. So depending on the method you use, you could add days, hours, minutes, or seconds, and even months or years to the date stored within our PowerTime date object. So as we've handled going forward, let's now handle going back to the past. We will prepare another object to handle a past date, exactly as we did before, picking up the current date and time using the now method. We're now going to take off 4 days from this date and time. And as we did before, we're going to push that information out to our log. If we run the application now, we will see that our past date has now gone back to Sunday, the 16th of March at 15:27. So we have gone back 4 days. So now we're going to tackle the final section of this video, the file times. As we did before, we're going to create a function to perform this. We'll call that file times. It's taking a single parameter, which is the path and the name of our current basic file, time and date handling.bas. Within this function, we're going to declare 2 local PowerTime variables, one called file and one called now. We've also declared 3 additional local variables, a user-defined type to hold the directory file information, a file name string which we're going to use to populate with the file name we've discovered, and a system time variable, which we're going to be populating. So we will first of all use the $$ command. This can quite easily be used to detect to see if the file exists. If the file exists, then the file name variable on the left-hand side will be populated. If it does not exist, this will be an empty length string. And in addition, this will pass the information to the dir data user-defined type. So if the file name is populated, we're then going to call a Windows API call, which is file time to system time. This takes 2 parameters, first being a byval var pointer, which is the dir data last write time. It's going to take the data held within that element and populate the file date variable. Having done that, we can now populate our PowerTime class objects using the new date method, picking out the year, month, and day from our file date variable. If we only wanted to check dates, then that's all we would have to do. But in this case, we're going to be looking at times as well. So we will use the new time method to populate those elements, the hour, the minute and the second. Now we want to work out how long it's been since the file was last updated and now. So first we will use the now method to populate the PowerTime object now. And then we can use the timeDiff method to work out the difference between these two objects. In this particular case, we know that the time difference between these two objects will be measured in seconds. The timeDiff method takes a number of parameters. The first parameter is the object we wish to compare to. So we're comparing the now object with the file object. Then the next thing is the sign. This will either have a value of +1, a value of 0, or a value of -1. If the value is -1, then the difference is in the past. If it's +1, it's in the future, and if it's 0, there is no difference. The parameters after that are days, hours, minutes, seconds. There are two additional optional parameters of milliseconds and ticks. In this case, we're only interested in seconds, so we can put by val0 for all the other parameters. Therefore, the only variable that's going to be populated is seconds. And in this case, I'm multiplying these seconds by the sign variable. That way, if the value was minus, it would amend the number of seconds accordingly. So we can now print out to our log how old this file is as compared to now. So if we run the application now, we will see that the file is currently 1 second old. If we wait a few seconds and run it again, we'll see the file is now 11 seconds old. So this file times function gives us a method to report on when the last time a file was written to. This can be quite easily used to determine whether a file is older or younger than a certain criteria. For example, if you wish to delete log files older than perhaps 30 days. So in summary, what we've done today is to look at 3 areas using the PowerTime class. Date validation, to determine whether a date is valid or not. Time periods, to move time slots forward or back. And file times, to work out how old a file is. Hopefully you'll find this functionality useful in your applications, but that's it for today. Thank you for watching.